So moving forward, let's invite our next duo speakers on the dais. Mr. Milan Rosina, Principal Analyst, Power Electronics and Battery, and Dr. Shalu Agarwal, Senior Technology and Market Analyst, Power Electronics, YOL Intelligence part of YOL Grow. They are going to talk about discover the latest market and technology trends shaping the power electronics industry in the renewable energy sector.
Yeah, hello everyone. Thank you for joining us. And my name is Dr. Shalu Agarwal, and here I have my colleague, Dr. Milan Rosina. And our presentation will focus on power electronic market and technology trends for renewables. But before that, a quick introduction of our company. So we both belong to the YOL Group. It's a market and technology research company, and headquarters is in France. But then we have worldwide presence, like in Asia, Europe, and USA, with more than 180 collaborations. Here is our expertise. So we focus on semiconductor industries. So it's related, like semiconductor packaging, semiconductor equipment, then compound semiconductors, and we also focus on batteries. And these are our three core activities. First is every year we publish market and technology reports. Second is tear down and reverse costing. It means, we have systems like inverters, converters, mobile laptops. We just tear down and try to analyze all the components of the system and also try to analyze the costing of those components. And third one is performance of electrical and electro-optical systems. Now, back to the presentation. So, we know that all the countries worldwide is trying to move towards carbon dioxide neutral society. So if we really want to move from carbon dioxide intensive society to carbon dioxide neutral society, then we have to cross the three pillars. First is electrification of everything. So anything which is generating carbon dioxide need to be converted into its electrical version. Like, for example, vehicle into electrical vehicles, two-wheelers into electrical two-wheelers, auto into e-autos. Second is electricity generation. So we try to produce more and more electricity from green sources like renewable sources, photovoltaic and wind. And third is energy savings and energy storing. So for example, we know that renewable energy sources like photovoltaic and wind, they don't generate, that constant electricity from 24 hours and 12 months. So in that case, it is very, very important to store the electricity. And second is electricity savings or energy savings. So for that, we must use those components in our systems like converters or semiconductor devices with high efficiency and lower losses. So here is the first pillar, electrification of everything. So for example, if we say that, okay, now I make electric vehicles and my electric vehicle doesn't generate carbon dioxide, so my product is completely green. But actually it's not true. If we really want to reduce the carbon dioxide footprint from our product, then we must use all the components in our product with reduction of or less carbon dioxide footprint. So for example, right now, if you see that end system players, for example, car OEMs, they ask their tier 1 company or converter company to reduce carbon dioxide footprints in their manufacturing process. Then tier 1 company asks their suppliers like packaging companies to reduce carbon dioxide footprint. And then they ask for device companies and the wafer companies and other products which are used in this end system like batteries, chemicals and material. So moving towards carbon dioxide neutral society is not impacting on the end system, but the whole supply chain. The second is energy generation by green sources. And everybody knows that right now we have two main green sources. One is photovoltaic and one is wind. Here you can see the main drivers for the growth of power photovoltaic market. First, we need to produce green energy. But then, like right now, you see that this photovoltaic market is very, very cost competitive with the fuel cell energy generation. Then most of the countries are providing incentives, and all the countries trying to become energy independent. So there are many drivers for the growth of photovoltaic. And due to these drivers, we see a strong growth in this photovoltaic market for last few years. There are more and more projects, there is strong deployment, now we start talking gigawatt and all. Second, you can see the main drivers for the growth of wind turbine. So again, it's like almost similar like photovoltaic market, that this technology is also cost competitive. Then we are providing, government is providing many type of incentives and all. And then here in wind turbine market also for last few years, we see a strong growth. And now we have big project, and then we also see that the size of the one turbine is also growing. And the third pillar is energy storage. Yeah, so especially with photovoltaic and wind. So for last few years, we see a strong growth in this battery energy storage market. The market growth of battery energy storage system is actually much higher than the renewable energy market. Because we need battery energy storage system to store our energy, and it also helps for the grid stabilization. It works as a power backup and all. And here you can see the power converter market overview. So actually, you can see the many markets, but this presentation is focusing on renewable energy. So let's see that photovoltaic market. So today already photovoltaic market has a very high market value. It's more than $23 billion by 2023. And then we see a strong growth in this photovoltaic market. So the market is growing with the CAGR of 6% from 2023 to 2029. The next is wind. So even though wind market is smaller compared to photovoltaic today, but you see there is a strong growth. The stronger than photovoltaic. So in coming years, we will see a strong growth in this wind market. Third is battery energy storage market. Today the market is quite small, but if you compare the growth, then battery energy storage system market has much higher growth than the photovoltaic and wind. And then we have other market segments also which belongs to towards carbon dioxide neutrality. For example, electric vehicles, and to charge electric vehicles we need EV-DC chargers, and for transmission of energy we need HVDC, and we see a quite decent growth in all these market segments. And now how this, the growth of renewable energy sources are impacting the power electronics. So like for few years, we see a strong growth in this PV and wind market. There is a bigger and bigger installation capacity. We talk in gigawatt. Few years back, we used to talk in megawatt, but now gigawatt. And for this high installation capacity, we need converters with high power, in terms of watt. And then we also need the converters with high voltage. And if our converters have high voltage, then obviously we need to use the semiconductor devices also with high voltage. And now my colleague, Mr. Milan, will explain you in detail that how this installation growth is impacting the power electronic market. Over to you, Milan.
Thank you, Shalu. So in the following slide, I will present you more the trends, how the supply chain and the technology will evolve in coming years. So here are the examples how the power converters, power or size of the converters is increasing over the last years. So it is comparison over the last 5 years, 2019, 2024. And the different examples are given from PV microinverters, string central inverters, also wind and battery converters. And you can see even in a short period, just 5 years, we see a huge increase in power. A huge increase in power, it means that if we keep the same voltage, we will get a problem with current. So the increase of the power will necessarily lead to the increase of the voltage. And here we have a slide that is presented what we call voltage game. That on the different systems, the voltage is increasing, and this drives the increase of the system voltage level also on the systems that are somehow interlinked with the system. So everybody knows the batteries for 100-volt vehicles and going to 800-volt vehicles. For the charge of those vehicles, we need the chargers that are rated at higher voltage level, so 500 volts. But to charge 800-volt battery, we need 1,000-volt charger in optimal case. And in photovoltaic, we see the trends to go from 1,000 volt to 1,500 volts, mainly for utility installations and commercial and industrial installations. But 1,500 volt is not the last step. There is already trends to go to 2,000 volts on the system level. And 1,500 volts is a kind of common voltage level where many players or many applications are targeting. So we see also the battery energy storage systems and eventually the charger for heavy mobility going to a 1,500 volt DC. But if we increase the system level, system voltage level, we have to increase also the device voltage, the devices that are used in those converters. So on the left side, you see the silicon technology, the conventional technology with silicon IGBT. They are already identified that there is a big move toward higher voltages, and they develop specific voltage ranges, voltage classes that are here shown in red color, which are different from the conventional ones, which are here shown in blue color. In silicon carbide, which is more recent technology, but which is promising higher performance and lower losses, we see that the arrival of higher voltage classes was later compared to IGBTs because we have still only a few products that are specified or dedicated to 1,500 volts. We see more and more players coming to the market. Recently, Wolfspeed had made an announcement about 2.3 kilovolt device, and other players will come. So this 2.x kilovolt class, this is really dedicated to 1,500 volt system levels. If you look on the silicon carbide, there was a lot of investment into silicon carbide, increase of manufacturing capacities. But at the same time, we see the reduced demand for automotive market, which is the biggest segment for SiC. That means that the players that are selling less for automotive, they would like to see other applications, other markets. So we consider that there will be a big boom of the silicon carbide adoption in industrial applications. And this has been confirmed already by the first devices that have been released, which are dedicated for high voltage systems like used in photovoltaics or battery energy systems. In gallium nitride technology, which is very promising also for some photovoltaic applications, like PV microinverters or PV string inverters, it's mainly about the lower power. But we have seen this technology is a little bit late in the development or deployment compared to silicon carbide. But recently we have seen two big acquisitions in this field from Infineon and Renesas that acquired two companies in gallium nitride area. This may be a strong signal to the industry that there will be a nice new application for gallium nitride that will bring much higher revenues compared to historical revenues coming mainly from consumer application market. Here is just one slide showing what is the positioning of the China regarding the power electronic area. You can see in the green histograms here in green pillars, it shows how China is independent in providing of different part of the supply chain. So China together with Taiwan, so the greater China is pretty independent in wafer, silicon and silicon carbide wafers. In packaged devices, converters and systems, China is also doing very well. And China has also very big domestic market, which is shown on the right side of this slide. In red color, you see the part of the Chinese end system within the global market. So China has a more than 50% of the PV market, more than 50% of wind market, and almost 50% of the battery energy storage market in 2023. So it's really dominating this market on production, but also on application level. And the trend is today towards made in China and for China. And the last big part of this, this complete environment for the power electronic supply is the bare die or the chip manufacturing. So China is putting a lot of resources, a lot of money into the development of bare die manufacturing inside of China and to provide bare die, the chips, to packaged device makers. So to conclude my talk, With Shalu, I hope we've shown that the market for renewables is driven by sustainable drivers, so it will continue to grow. And PV and wind energy markets can't exist anymore without battery energy storage systems. So we consider the stationary battery energy storage system will feature very, very strong growth in CAGR in the coming years. And this application represents a lot of opportunities for power electronic makers, both on system and the device level and down also to wafer levels. The EV market showed currently a deceleration, so still growing, but at a much lower speed. It means that it brings the opportunities for industrial applications because there will be much more focus on industrial applications. So thank you very much for your attention. And if you have any question, please join me and Shalu here at the table, and we will be glad to answer your questions. Thank you.